Prove that cos squared x is equal to a half cos 2x plus 1, or it could be equivalent to, and that sinh 2x is equivalent to 2 sinh x cos x. Hence finds the integral of the square root of x squared plus 9 dx using the substitution x is equal to 3 sinh u of u. Right, so we've proved the identities first. We are going to use these identities in order to solve this integration. So we've got to prove cos squared x is equal to a half cos 2x plus 1. So cos squared x, if we rearrange this identity which I proved in a different video, which is cos squared x minus sinh, or sine if you prefer, sinh squared x is equal to 1. We get cos squared x is equal to 1 plus sinh squared x. So this will be equal to a 1 plus e to the x minus e to the minus x over 2 all squared. So this is going to be 1 plus e to the 2x minus 2 plus e to the minus 2x over 4 when you square the 2. Making a common denominator, we're going to get 4 plus e to the 2x minus 2 plus e to the minus 2x over 4. 4 minus 2 will give me 2. So we're going to get 2 e to the 2x plus e to the minus 2x, and then I'm going to take out 2 from the common denominator. So the denominator here is now 2. So that now gives me a half of e to the 2x plus e to the minus 2x over 2. Then 2 over 2 obviously is 1. And then that's going to give me what I want, because this is cos 2x. So we've got a half cos 2x plus 1. For the second identity, which is sinh 2x is equal to 2 sinh x cos x, I'm going to use this one first. So take 2 sinh x cos x is equal to 2 e to the x minus e to the minus x over 2, which is e to the x plus e to the minus x over 2. Now you might notice here you have the difference of 2 squares, which is equal to a squared minus b squared. So this will be equal to 2 e to the 2x, because that's what e to the x squared is, minus e to the minus 2x over 4 when you do 2 times 2. And then here, the 2 and the 4 cancel, so we end up with e to the 2x minus e to the minus 2x over 2, which is the same as sinh of 2x. Right, we'll now use these identities to solve the integral. Right, so we've got the integral of the square root of x squared plus 9 dx. Okay, this is quite long and involved, so please feel free to stop and explore at any time. So you're told the substitution is x is 3 sinh of u. When you do integration by substitution, the first step is to differentiate. If you differentiate 3 sinh you get 3 cos u, and then rearrange for dx. So dx will be 3 cos u du. So my integral will become the integral square root of x squared plus 9 dx will be equal to 3 sinh u squared for the x squared plus 9, taking the square root of it all, times my dx, which will be 3 cos u du. Okay, carrying on. So when you expand this, you get 9 sinh squared u plus 9, and then you get 3 cos of u. Now, if I take out 9 from there, it becomes 3, and then combine it with that 3 there, I'm going to get 9 sinh squared u plus 1 times cos u. Now, we know that cos squared u minus sinh squared u is equal to 1, and therefore that sinh squared u plus 1 is cos squared u. So I'm going to now put in here the square root of cos squared u cos of u du. If you square this and square root it, you get back to cos u, but then if you combine it with that, it becomes 9 cos squared u du. Right, now we can use what we have proved in the first part of the question, which is cos squared u is equal to half of cos 2u plus 1. So we'll replace this with that. So it becomes 9 over 2 of the integral of cos 2x plus 1 du. We're now in a stage where we can integrate. So we've got 9 over 2. If you integrate cos, you get sinh 2x will become, I want to correct myself here, this should be a u, because it's in terms of u now. Okay, so what we do now is, if we integrate cos 2u, it comes from sinh 2u. When you differentiate sinh 2u, you get 2 sinh 2u, so therefore I need to compensate it with a half. So it becomes a half sinh 2u plus u plus c. Right, now we've got to replace all the u's and get back to what we started with, and this is the tricky bit. So we've got sinh 2u is 2 sinh u cos of u. So that this now becomes, because we've got half, I'm going to replace this as sinh u cos u plus c. We don't, it's a half because we got half of this, so we don't need the 2. And then we know that x was 3 sinh u from the substitution. Therefore, sinh of u is x over 3. And therefore, cos of u is going to be sinh squared u plus 1, which is going to be the square root of sinh, which is x over 3, but it has to be squared plus 1. And then we should know by now, if we take the 3 up there, it'll become 9, so 3 squared, so 3 squared over 3. And then when we take the 3 out, we get 1/3. So this will become 1/3 of the square root of x squared plus 9. Right. Okay, so this becomes 9 over 2. Sinh u is x over 3. Cos of u is 1/3 of x squared, square root of x squared plus 9. Plus my u, well, so u will be arc sinh of x over 3 from here. So this becomes arc sinh of x over 3 plus c. Right, just one last step now. 3 times 3 makes 9. So that 9, if I take it out, will cancel with that 9. I'll still get a half in front, but I will have to put a 9 here. So the final answer will be 1/2 of x times the square root of x squared plus 9, plus that 9, arc sinh x over 3 plus c. So it's quite long and involved this question. Okay, this has been a video to show you how to prove some hyperbolic identities and then use it in a substitution. I hope you've understood, and I thank you very much for watching.